Hello friends, good morning. Welcome back to the class. I hope you all are safe at home and healthy too. So in this session now we are going to discuss the properties of determinants. So already we have discussed the meaning of the determinant of a square matrix in the last session as a session number 1. In that session, we also discussed how to determine the determinant of 2 by 2 matrix and 3 by 3 matrix. Now, in this session, we are going to understand some important properties of determinant to solve the determinant in easiest manner. As you know, the properties are formulas, are identities, are developed just to calculate the things in easiest manner. Just like in geometry, to calculate the area and volume of any geometrical figures, right, we have developed certain formulas. So formulas are basically help us to find out the particular things in a easiest manner. In a similar way, here the properties of some determinants are developed to just to calculate the determinant in easy and very smartest way. That is why it is necessary to understand the properties and remember the properties and to apply the properties. So here in this topic we have total 14 properties. Correct? There are total 14 properties related to determinants we have, but in this session we are going to discuss only and only 11 properties. Reason is that the remaining 3 properties are related to minus and cofactors, and that will be introduced in the session number 3. So hence here we are discussing only 11 properties. So let's try to understand these properties with an example directly in the easiest manner, step by step. Let's start with the session. The first property, I'm naming the properties as P1, P2 like that. So what is the first property I'm speaking about? The property number 1, if I say the determinant of diagonal matrix, determinant of diagonal matrix. What is the special characteristic property of diagonal matrix? You know that diagonal matrix means it is a square matrix only, where only it has diagonal element, other elements are 0. So I am taking one diagonal matrix of 2 by 2 order. Let us say the matrix A is a diagonal matrix 2 0 0 3. So if I want to find the determinant of this matrix, what I will get? Determinant means determinant of A. It means determinant of 2003. And you know how to calculate 2 by 2 determinant just by doing the product of the diagonal elements first. That is 6 minus, then other two element product is 0. So 6 minus 0 is what? 6. Simple. So what you have understood from this example is that simply it's a product of diagonal elements. You may also take 3 by 3 matrix here. So I am taking a 3 by 3 diagonal matrix, and by expanding that matrix you will get the answer as a product of the diagonal elements only, and this is the property of diagonal matrix. Now if I am taking a 3 by 3 matrix, let the B matrix is 1 0 0 0 2 0 0 0 3. So this is a 3 by 3 square matrix. Now I want to find the determinant of this matrix. So how can I find the determinant? Simply by writing the determinant of B. It means determinant of this matrix. Simply. So this is a symbol to represent the determinant. Now I wanted to open this or expand this 3 by 3 determinant with the help of row 1. With row 1. So I am expanding this with row 1. And what is the process to find the determinant? Simply element multiplied by its position and multiplied by its corresponding 2 by 2 determinant. That is what? Element 1 is an element, then minus 1 to the power of I plus j. I plus j means first row, first column position. First row, first column into determinant of 2 by 2 matrix by eliminating the row and the column of the element 1. So we are left with 2, 0, 0, 3. And the next plus element 0. So no need to expand again because 0 into something is always 0, 0 into something is always 0. So it's so simple to find the determinant in this manner. So what you will get 1 into minus 1 to the power of 2 is again 1. The 2 by determinant value already we have learned, this diagonal elements is 6. So hence the total product is 6. So this value can also be obtained simply by multiplying the diagonal elements 1 into 2 into 3. You will get 6. So in this manner, if I am giving you the diagonal matrix in a short form, diagonal matrix of the element 2, 3 and 4. So ultimately your answer would be determinant of this value. If I say the element matrix A is given as this, so det A value you can simply say it's a product of diagonal elements. So it would be what, 24. So I hope you have understood the concept of the first property. What is the first property speaks in short? The determinant of diagonal matrix is just the product of diagonal elements, nothing else, whether it is a 3 by 3, 4 by 4, 2 by 2, 6 by 6, whatever the order, but it must be a diagonal matrix. That's it. Now we are going to understand the second property of the determinant. Right. Now I am taking the property number 2. Property number 2. What is this property speaks? Importantly, it's talk about skew symmetric matrix. You know what is by skew symmetric matrix? Yes, you know it very well. Skew symmetric matrix means a square matrix which satisfying the condition A transpose is equal to minus A. So this is a square matrix is known as what, skew symmetric matrix. And what is a characteristic property of skew symmetric matrix you have studied? See, if I write the skew symmetric matrix, so ultimately all diagonal elements of skew symmetric matrix is always 0. So I can write an example of skew symmetric matrix by writing the diagonal elements as 0 and other diagonal elements are differ by sign. Let us say this element is 2, so the other element would be minus 2. I can also give the 3 by 3 3 by 3 matrix which is a skew symmetric matrix. Let us say first I will write the diagonal elements of this skew symmetric is always 0. Now if I keep this element as 2, so diagonally opposite element would be minus 2. If I keep this element as 3, so diagonally opposite element would be minus 3. If I keep this as 4, so diagonally opposite element is minus 4. So this is an example of 3 by 3 skew symmetric matrix and this is an example of 2 by 2 skew symmetric matrix. Now what is the property number 2 is talking about? If it is a skew symmetric matrix, you may see that the determinant value, just I am talking about the determinant value. So what is the det A value? So det A means determinant of 0, 2, minus 2 and 0. So if you calculate this value, what you will get? The product of the first two element is 0 minus product of the other two element is minus 2. So the answer is a 4. Just keep it aside. And then calculate the determinant of 3 by 3, 3 by 3 matrix. So I wanted to calculate the determinant of B. So det B is equal to, first I am again using the row 1 elements. I am expanding this determinant with the help of row 1 elements. Means only 3 elements I am going to use. So first the element 0 into minus 1 to the power of its position. What is the position of 0? I plus j, that is row plus column, that is 2 into determinant after eliminating this row and particular column. So what you will get? 0, 4, minus 4 and 0 plus. Then the second element. What is second element? We have 2. So element is 2 into minus 1 to the power of first row, second column. So power would be sum of the row and column into determinant. What is the determinant? By eliminating the particular row and column. So we are left with minus 2, 4, minus 3, 0. And the third element. What is third element? 3, which is multiplied by minus 1 to the power of its row and column. It would be first row, third column, hence the power would be 4 into the determinant. While the determinant value, by eliminating the row and the column, we are left with minus 2, 0, minus 3, minus 4. Minus 2, 0, minus 3, minus 4. Now just we need to calculate this value. Just see what happens. 0 into something is, the product completely will be 0. So I am writing 0 only directly. Plus minus 1 to the power of 3 is minus 1 only. So minus 1 into 2 is what? Minus 2 into the product of this value. So 0 minus of minus 12 is plus 12. Product on a crisscross, cross multiply type. Then minus 1 to the power of 4 is positive 1 into 3. It's positive 3 only. And the product here, if you multiply these values, you will get 8 and rest with 0. So 8 minus 0. So finally, if you calculate this value, it's minus 24, it's plus 24, the sum will be 0. Now what we wanted to conclude from these two calculations. If we observe the skew symmetric matrix of 2 by 2, then answer is a perfect square number. 4 is a perfect square number. Similarly, if you observe the 3 by 3 skew symmetric matrix, its determinant value is always 0. So this is the important conclusion from this calculation. So what I am going to define as a property number 2 is the skew symmetric matrix. For a given skew symmetric matrix, if the order is even means 2 by 2, 4 by 4, 6 by 6, 8 by 8. So definitely the determinant value is a perfect square number. It may be any perfect square number. 4, its answer may be 4, its answer may be 1, its answer may be 9, 25, 16, 49, 81, like this. But order must be what? Even order. Even order means 2 by 2, 4 by 4, 6 by 6 and so on. But when you take the order, that is what? Odd order. 3 by 3. 5 by 5, 7 by 7, 9 by 9. Like this type of skew symmetric matrix you have taken. So that determinant value of that matrix, odd order matrix, is always 0. So while while solving this type of question, no need to waste your time. If it is an odd order, directly by using this property, you can simply write its answer is 0 by stating this property statement as a reason, right? Because it's a skew symmetric matrix of odd order, that's why its answer would be 0. No need to calculate even because it's a standard result. So that is the use of properties of determinant. Okay. So this is property number 2. So property number 1 related to diagonal matrix. Property number 2 is related to skew symmetric matrix. Now coming to the property number 3. What is the property number 3 we have? See, it's so simple, it's so easy to remember and to apply, right? What they are saying that determinant of a square matrix, that is always no need to say here square matrix again and again because determinant means to square matrix, nothing. Okay, it determinant is to square matrix only. उसके अलावा और किसी मैट्रिक्स में determinant होगा ही नहीं, right? So determinant of a square matrix A is equal to determinant of its transpose. It means by doing the transpose, right? So we can say that after doing the transpose also the determinant value will not change. Let us take an example to understand this property. For example, I am taking 2, 3, 5 and minus 6. So this is a matrix A. Now I am doing the transpose of this matrix. Transpose means interchanging of rows and columns. I am interchanging row and column. I am taking the row 1, I am writing column 2, 3. Second row becomes second column. Nothing else. So this is transpose, this is a given matrix. Now I am calculating the determinant value of both the matrices. Det A means product of these two first, that is minus 12 minus product of these two, it would be 15. So answer is what? Minus 27. Now I am calculating the determinant of its transpose. So determinant of its transpose is again the product here minus 12 minus product of other two elements 15. You can see the answer would be same. Hence what we can say, determinant of matrix A is equal to determinant of its transpose. So det A is equal to det A transpose. So this is property number 3. Now coming to the property number 4. What is the property number 4? Property number 4, that det of AB, where the product exists, ultimately both are square matrix, product of AB is equal to product of det A into det B. Det of AB is equal to det A into det B. So you can understand this property with an example. I am taking two different matrices, square matrix of 2 by 2 order. It is so easy to understand by taking 2 by 2. It will save our time, nothing else. You may apply the same property for n order, 3 by 3, 4 by 4, 5 by 5. So I am taking the first matrix as 1, 2, 3, 4. And the second matrix I am taking like 2, 0, 0, 3. Now what I am doing first, I will calculate first product of these two matrices, and you know how to get the product of two matrices, first row first column, like means I am going to get the 2 by 2 matrix just by doing this way. Okay, first row first column element, so 1 2s are 2, 2 zeros are 0, the total sum is 2. Similarly, now the first row second column, this element, how can I get? Just by multiplying the corresponding elements and adding them, you will get 6. Second row first column, it would be 6 and 0, that would be 6. And the second row second column, 3 zeros are 0, 4 threes are 12, the sum is 12. So I am not having A, B and AB. Now I need to calculate the determinant of these three matrices individually. So I am just calculating det A. What is the det A value? Can you speak orally? See, 4 ones are 4 minus 3 twos are 6. So 4 minus 6 is minus 2. Similarly, for the second matrix B, det B value, what I can say, 6 minus 0 is 6. And determinant of AB, what I can say here, 12 twos are 24, 6 6 are 36, 24 minus 36. 24 minus 36 is minus 12. So you can see the product of A into B, that is mod A into, sorry, not mod A, it determinant. So det A into det B is, it will give minus 12, that is equal to det AB. So from here I can say det of AB is equal to det A into det B. And this property you may generalize like determinant of ABC We can write it as det A into det B into det C. So this is what the generalized one. So we may extend for n number of matrices. So I hope you have understood the four properties here. First property is related to diagonal matrix, second property related to skew symmetric matrix, third property related to transpose of that matrix is remains same, det A is equal to det A transpose, and the fourth one is det AB is equal to det A into det B. Now coming to the property number 5. Basically, these all properties are helpful while calculating a difficult determinant values. You will see these concepts in the second exercise, right, as you have in our syllabus. Now, property number 5. What is this property number 5 speaks? If you interchange any two rows or any two columns, then determinant value will remain same. It's just differ by a sign. I repeat, if you interchange any two rows or column, then the determinant value is differ by its sign. Let us see. Uh, a matrix A is 2, 3, 4, 5. So what the determinant value of this matrix is 10 minus 12, that is minus 2. Similarly, now I am interchanging the two rows, means R1 and R2 are interchanged. Let us say R1 and R2 are interchanged. Then the new matrix which so obtained is B. That is what 4, 5, 2, 3. Now calculate the determinant of this matrix which is obtained, which is equal to 12 minus 10. That is what? 2. So what we have observed, the value of the determinant after interchanging the rows, just numerically they are same, magnitude wise they are same, this they are differed by a sign. If the det value of first matrix is minus 2, det value of second matrix is plus 2. Similarly, if I ask that the determinant of a matrix A is 15, right, after interchanging the row 1 with row 2, what is the value of determinant A? Then it would be minus 15. Simply by using the property you can say, no need to calculate even. So this is the property number 5. So what it speaks? If you interchange any row or any column, then the determinant value is differed by its sign only. Okay, so this is property number 5. Now property number 6. It's very interesting. Property number 6. People love to remember, used to, है ना, उसको यूज करना प्रॉब्लम्स के अंदर बहुत मजा आता है. Property number 6. Very interesting property. What it speaks. Property number 6 बोलता है कि right, if any row elements of all the elements of any particular row or a column are zeros, then determinant value becomes 0. What does it mean? If I take the matrix as 0, 0, 2 and 3. Here you can observe that all the elements of row 1 are zeros. Hence, its determinant value is 0. Let's see whether this property correct or not. Det A would be 3 into 0 is 0, minus 2 into 0 is 0. The answer is 0. So whenever you got the step like in between wherever the entire the elements of a row or a column are zeros, then blindly you can say the net value becomes 0. And you have experienced this property while doing the elementary operation in matrix chapter, while calculating the inverse of the matrix with the method of elementary operation, right? So you have already experienced this property. So this is what we called as what? The sixth property here. What is the sixth property speaks? If any entire element, all the elements of the row or a column are zeros, then determinant of that square matrix is always 0. Now if I am giving you one matrix, you can simply speak what is the det value. 1, 2, 3, 0, 0, 0, 4, 5, 6. What is the det value here? 0. Reason? All the elements of row 2 are zeros, hence det value is 0. No need to even calculate, no need to even expand it. So this is a use of properties of determinant to calculate the det values. Fine. So property number 6 is clear. Now coming to the property number 7. Right. So property number 7 speaks what? Any two rows or columns of the square matrix are identical, then its det value again 0. So 0 होने का chance दो तरीके से हो रहा है. One, कि where the elements of any particular row or column is 0, then det value is 0. Where the two rows or two columns are identical, then also det value is 0. Let us see the matrix I am taking. 2, 3, 2, 3. If you see here, the example which I have set is row 1 and row 2 are identical. Even column wise also you can see here, coincidentally, column 1 and column 2 are identical. When two rows are identical, or what we say that if two columns are identical, then det value is 0. This is the property number 7. So det A is what? What you will say that A value is? Simply 6 minus 6. It's 0. Why did that value become 0 here? Particularly, here the two rows or two columns are identical. If I am giving you the 3 by 3 matrix, 1, 2, 3, 4, 5, 6, 1, 2, 3. So what we have observed in 3 by 3 determinant matrix is 3 by 3 matrix is row 1 and row 3 elements are identical. Hence, what we called here det B is directly 0. No need to calculate. What is this property speaks? Clear? Apart from this property, there is a other statement can also work. Property number 7 के अंदर हम एक और point add कर सकते हैं. If you got the any rows are proportional, let us say proportional means the ratio of the row 1 elements and the row 2 elements. Let us say here if you take two rows, these elements are in proportion. Let us say 2 by 4 is 1 by 2, 3 by 6 is 1 by 2. Hence here row 1 elements are proportional with row 2 elements, then also the determinant value is 0. You may say they see 6 to the 12, 4 to the 12, 12 minus 12 is 0. So this property will also include in property number 7. So the determinant value is 0 when the any two rows or columns are identical, or also you can speak if the any two row elements or column elements are in proportion, then also determinant value is 0. Now to take this example, I am just taking the 3 by 3 matrix. What is the determinant value by using this property number 7? I am taking 2, 3, 4, 1 minus 1, 0, and it is 8, 12 and 16. If you observe this 3 by 3 square matrix, here the row 1 elements and row 3 elements, R1 and R3 elements are proportional. 2 by 8 will give 1 by 4, 3 by 12, 1 by 4, 4 by 16, 1 by 4. Hence, row 1 and row 3 elements are proportional. Hence, the determinant value becomes 0. No need to expand, no need to calculate further. Simply by using this property, you can speak here R1 and R3 elements are proportional. Hence, the get value is 0. So this is the property number 7. I hope it is very clear. If any two rows or columns are identical, or else if two rows or column are proportional, elements are proportional, then also the determinant value becomes 0. Now coming to the property number 8. And what is this property number 8 speaks? Right. If if a square matrix is multiplied by a constant, let us say the matrix A of order n by n. A is a square matrix of order n by n, then it implies that determinant of k times of this A, k is any non-zero real number, then its value is simply written as k to the power of n into det A. It's very important property. Based on this, many a times the questions are being asked in the boards. So please keep this as a formula in your mind. Now, what I am speaking here, if matrix A of order n by n, then determinant of k into A is written as k to the power of n into det A. What does it mean? If I take the matrix A of order 2 by 2, which is simply 1, 2, 3, 4, then what is the determinant value of this matrix? It's simply 4 minus 6, that is minus 2. Now if I multiply this entire matrix element with 3, let us say मैं 3 से multiply करा, so 3a, 3 times of this matrix is equal to what? Every element of this matrix is multiplied by 3. So it will be 3, 3 to the 6, 3 3 the 9, 3 4 the 12. Now if I want to calculate the determinant of 3a, what the value you will obtain here? 12 3s are 36 minus 9 6 are 54. 36 minus 54. 36 minus 54. What you will get as a result here? Uh, 10, 14, 18. That is minus 18. Answer would be what? Minus 18. So there is a connection between these two values. Here, minus 18 can written as 9 into minus 2, which will be written as 3 square into minus 2. Now if you observe, these answers here, this property is already verified. See, what is a constant by which the matrix is multiplied? By 3. So ultimately the det value, that is minus 2, is the det value of the original matrix, that is multiplied by how many times? 3 square times. It means how we'll get this quantity directly? This is the 3 is treated as here, k as a constant, and its power is basically the order of the given matrix. Order of the given matrix. So what is the power here? 2 by 2 matrix. That's why the order power is taken as 2. Simply, if I multiply any constant with 3, then the det value here becomes 3 to the power of n representing the order of the square matrix, k representing the constant by which that matrix is being multiplied. So this is a very important property. Now based on this, I am going to ask one question. Right. Now a determinant of the matrix of 5 by 5 order, where the det value of this matrix is 2. I am saying what? I am saying here, if a matrix of order 5 by 5 whose det value is 2, then what is the value of, then find the value of determinant of 5 times of this matrix. What is the determinant det value of 5a? So simply this value can be calculated by using this property. So det 5a is nothing but, det 5a is nothing but 5 to the power of 5 into det A, because 5 is a constant, it remains same. Its power representing the order of the square matrix, order is 5, hence 5 power 5 into det A. So 5 power 5, what's the value, into det A value is what? 2. So 5 power 5 means what, you can say? It is just 625 into 5 into 2, That is what 6250 over. So I hope you have understood this property number 8 with an example also. With the property also they are going to ask. ये question है जो boards में repeatedly पूछा है. So if I change the order, the power will interchange, nothing else. If I change the constant, then this product, the base will be interchanged. That's it. Okay. So property number 8 is over. Now coming to the property number 9. Right. Property number 9. In property number 9, what is this property number 9 speaks about? If a matrix, in a square matrix, if any row or a column is multiplied by a constant, any row, I am talking about any particular row or particular column is multiplied by a constant, then entire determinant of that square matrix is multiplied by the same constant. What does it mean? If a square matrix, I am taking about here the square matrix of 2 by 2. This is 3, 4, 5, 6. So, what is the dead value of this square matrix? Simply 18 minus 20, that is minus 2. Now, what I am speaking here, if let us say the row 1 elements, I am taking the entire row. Row 1 को मैंने change किया, row operation, which you have already used in matrix chapter. Row 1 is going to change just by multiplying the row 1 element by 2. Or you may also take 3, 4, 5, whatever the constant, whichever we like. If I multiply the entire row with 5, only particular row, I am not multiplying the entire matrix here. So ultimately what you will say here, that the new matrix which so obtained is, that is what, 5 times of 3, 15, 5 times of 4, 20, remaining second row will remain same. So if I calculate the determinant of the matrix so obtained is what? 15 6 are 90, 25 is 100, 90 minus 100 will give minus 10, which can be written as 5 times of minus 2, which is basically a 5 times of det of A. So therefore, determinant of B is just a 5 times of determinant of A. So have you understood something from this example? Det A value was minus 2. If I multiply a row, a particular row or a column with a constant, then the determinant value is also multiplied by the same constant. So this is what determinant value was minus 2, which is multiplied by 5, which will give minus 10. So now in a similar manner, now I can ask the same. Right? See, without showing the elements of the matrix to understand this property. If determinant of a square matrix is 20, right? Now the row 1 elements are multiplied by 5. Then what is the value of, after this operation, what is the value of det A? It's simply what you will say 5 times of this value, that is 100. You are using this property. If row 1 elements are multiplied by 10, then det A value is multiplied by 10. If it is multiplied by 20, the det A value is also multiplied by 20, like this. This is the property number 9. So this property also speaks the important result that has a subpart. Similarly, if I have a common factor in a particular row or column, I can take that common factor as a common factor of determinant. Let us say, to understand this concept, I am taking 20 and let us say here 12 and 5 and 3. If you see, the row 1 elements are the multiples of 4. 4 is a highest common factor of 20 and 12. So hence I can write this as 4 into 5 and this element as 4 into 3. 5 and 3. See, if I take that one, 4 as a common factor, I can take from row 1. My row 1 say 4 common factor type looks it now. So I can take 4 as a common factor. We are left with 5, 3, 5, 3. So here the two rows are identical, our two columns are identical, hence its value is 0. 0 into 4 is 0. This is a use of this property number 9 to calculate such determinants. You may also calculate directly. See, 23 is a 60, 12 5 is a 60, 60 minus 60 is 0. This is a direct way. If I'm using the property, what I'm looking here, I have observed that row 1 elements have some common factors. I took that common factor as a common factor here, and then the remaining elements become identical. So ultimately, if two rows or columns are identical, that value is 0, hence 5 into 0 or 4 into 0 is always 0. So this is the use of this property number 9. Now coming to the second last property of today's session, property number 10. What is this property number 10? We are going to use this property number 10 frequently. हम बहुत बार use करेंगे in this chapter, in this exercise. See, what is this speaks? If any matrix A, 2, 3, 4 and 5, if you are applying any row operation or any column operation, then the det value remains same. It means what? What is the det value of the given matrix first? Initially, it is 10 minus 12, that is minus 2. Now, what I am applying? I am just applying the row operation in the matrix. Row 1 I am going to change just by what? Row 1 plus 2 times of row 2. What I am going to do in row 1? Row 1 is added what 2 times of row 2. This is what row operation. You have used this row operation many times in the previous chapter, matrix chapter, while calculating the inverse with the help of elementary row operation technique. So I am applying the row operation here. If I do this way, what the matrix I am going to get? The new matrix. I am going to change row 1 elements. How the row 1 elements are going to change? Row 1 plus 2 times of row 2. So 2 plus 2 times of 4, that is 8. 8 plus 2 will be 10. Row 1 element 3 plus 2 times of 5, that is 10. 10 plus 3, that is 13. And remaining is what? 4 and 5. Now again, try to calculate the determinant of this value. What you will say that value is? 10 5 is a 50, 13 4 is a 52. 50 minus 52, the answer remains same. See, there is no change in the answer. It means that if you are applying any row operation or a column operation, then it does not affect the determinant value. Okay, what I am repeating here, if you are applying any row operation or a column operation, it does not change the determinant value. So whenever, wherever it is required, you can apply the row operation or column operation to make the simplification easy. So this is the use of property, this property number 10. Now coming to the last property of this session, that is property number 11. What is this property number 11 speaks about? It's so interesting. Sometimes it's useful, very useful in solving the particular typical sums. See, if any matrix is expressible as, let us say I'm taking a variable to understand this, a plus x and b plus y, and it is c and it is d. If you observe, the row 1 elements are expressible as what are written as sum of two numbers or two variables. Sum of two variables. Hence, this determinant of this determinant means a plus x, b plus y, c and d. this can be written as a sum of two determinants in a simplest manner by taking the first variables, that is first elements of the sum in the row 1, and the second elements x and y are taken in the second determinant, and the row 2 elements remain same in both the determinants. You may express the determinant into some of the two smaller determinants if the all the elements of the row or a column is given as a sum of two variables, then you can write this determinant as the sum of the two individual determinants by taking the first elements in the first, second element, corresponding element in the second determinant, by keeping the other rows are undisturbed. Clear? So this is a simple property. You may solve the left hand side determinant and right hand side determinant. You will get the answer will be same. You can see here what is the determinant value. You can see this, verify this property by taking LHS and RHS by simplifying it. So A plus X into D will be what? AD plus XD minus C into B plus Y is minus CB minus CY. This is the left hand side portion done. Now, what is the RHS? What we have? AD minus BC plus DX minus CY. Now, group B positive terms first. AD plus DX minus BC minus CY. You can see these two are results are same. So, left hand side is equal to right hand side. I hope you have understood the property. If the any elements of any row or column, elements of row or column are expressible as a sum of two or more than two elements, then that determinant can split into two smallest determinants by taking the corresponding elements in first and second by keeping other rows or other columns undisturbed. So this property will help you out to find some interesting questions. See, if I take that, how this property can be helpful to find a determinant, and taking the one small question to understand. The square matrix, which is given as 2 plus x and 3 plus y and 2, I'm taking 4 and 6. Now I want to find the determinant of the square matrix. Now how can I use this property number 11 to solve such type of questions, right? So determinant of A is nothing but determinant of 2 plus x, 3 plus y, 4 and 6. Okay, so this can be written as 2, 3, 4, 6 plus the other element, second element is x and y. So plus x and y by keeping the row 2 elements undisturbed. Now if you see here, the two rows elements are proportional. The elements of R1 and R2 are proportional. 2 by 4 is 1 by 2. 3 by 6 is 1 by 2. Hence its value is 0 because as property is fixed. And plus, and to calculate this, it's so simple by simply doing the crisscross multiplication. 6x minus 4y. The answer is 6x minus 4y. So this is the way of applying this property to simplify the things. You may see, sir, it's already 2 by 2. Why we are doing this property? We may calculate directly by doing so. Yes, you may do it, but you can do because of it is a 2 by 2 matrix. If it is a 3 by 3 matrix, you will definitely looking for some helping hand, and these properties are the helping hands to for us to calculate the difficult determinant values in a simplest manner. So I definitely here wanted to say that please remember these 11 properties as 11 mantras of this chapter. I would say these are the 11 mantras of this chapter. If you are thorough in these 11 property statements, then you will see the easiness while calculating the debt value of the difficult expressions, okay, that we have in a second exercise as NCERT textbook, right? So here I am ending up this session with these properties only, and we will see how to apply these properties in the session 3, where I am taking a specific 10 to 12 sums to understand the methodology, understand the techniques to apply these properties. So meanwhile, I will suggest all you that keep on watching this session too, and try to make a notes and try to understand, try to memorize these 11 properties to make your work easy. So thank you all of you, and always keep on doing, and keep on doing, and become excel in yourself. Thank you all of you once again.